Okay, so in the last video, we went through finding the reactions and then setting up all of the equations. So this time through, we're gonna draw this all graphically. So I'm gonna erase all of this nonsense. So if you did this graphically, I mean equations, then you can go back now and you can check your equations with what we find graphically. So remember when we're finding shear moment diagrams as we're coming down, we're just integrating. We're just literally finding areas under the curve. If I have a shear, okay, so I have the shear coming down. If I look internal, I'm going to have equal and opposite, which means we have negative shear. And that's why we are allowed to just follow the direction of our shear. If I have externally a shear going up, I've got to have an internal, by behavior now, positive shear. And so literally follow the direction. So I'm at -5. And what I do is usually just keep a running total on my calculator, okay? I'm going to try to move it over. So, okay, so I have a -5 coming down. Nothing happens, so if I change sign enter, I'm going to come up 17. My reaction is going up, so I come up to 12. So we're going to kind of like try to make this somewhat, I don't know what the scale is because I haven't worked this problem, okay? And when I come up with 12, I'm now reducing with a linear load of, 2 times x. So if I have 2 kips times 8 feet, 2 times 8, I have 16. It's going down, so it's a -16. So I have my 12 minus 16 equals 16 minus -4. So I'm going to go from 12 to -4. And this is linear. So we have a first order curve here coming down. And I came down, like I said, to -4. Maybe go like this, -4. Okay. And then I'm going to shoot straight up 15 plus, and I'm back up to 11. So we'll just signify that that's an 11. Back up to 11. And then I have 2 times 12 going down, so that's a -24, 24 minus. And I'm down to 13. So we can come down to about here, -13. And again, this is constant, so we have first order here. I'm at -13. I don't remember what my reaction was. I think it was 23. Okay, so I had a 23 kips coming up. -13 plus 23 is 10, so I'm going to come up to 10. And it's constant. And then I'm going to come down 10, and I've kind of closed it. So we can see we have quite a few little areas here. We're going to have to figure out where our shear is 0, which is the beauty of the equations, honestly. Okay, so I have, now we just start with areas. I have area equals negative base, and height. 5 feet, -5, so 5 times 5 is -25. And let's just go ahead and start this like that. So we'll be putting our moment down here, moment of kip feet. Okay. Okay, so again, I have to figure out where my shear equals 0 because that's where I have, from a positive slope to a negative slope, it's going to be one of my critical points I need to look at. It's either a max or a min, at least a local max or min. Okay. So I need to, and look, I'm going to have to do the same thing over here, okay? And then this one's pretty easy. I have a positive area. It's above 10 times 3, positive 30, okay? So that's the easy one. So how do I find where this crosses? Well, I'm super visual. And again, I'm going to look at, here's a triangle. See that big triangle like that? Okay. So if I come over here, here's that triangle, like so. The base of that triangle is 8, and the height of that triangle is actually 12 plus that -4 equals 16. Okay, so the whole height is 12, and then I have to go down 4, and the whole base is 8. So I'm going to have 8 is to 16 as, okay, now I've got this term x, okay, so we've got this same slope, so here's my term x, and my height is 12. X is to 12. So I'm going to have 8 enter 12 times 16 divided by, and I get 6 feet. So X equals 6. So when I come back over here, I can see that this value is 6. That means this value is 2. So if I want the area, what is area of a triangle? 1/2 base times height. So I'm going to have, okay, 0.5, enter, 12 times, 6 times, and I have an area of 36. Okay, so it'd be 12 times 6, well, it's 12 times 3 is 36. This area is negative. See this negative? So this was a positive area. This one's negative. Base is 2, 1/2 base. Well, that's just going to be 1 times -4. So this area equals -4. Okay, now I've got to do the same thing here. So I've got a big triangle. Let's see if you can kind of see this big triangle. So I have a big triangle, and my whole base is 12, and I'm going from 11 down to a -13. So it's really 11 plus 13, so that's 24. Okay, and then I've got this inner triangle. Okay, so I've got this small one here, and when I look at the small one, it is X times 11. So I have X is to 11 as 12 is to 24, and I can take 12, enter, 11 times 24 divided by, and I get 5X equals 5.5 feet. So this is 5.5, which looks about right. It's not quite in the middle. That means this has to be 6.5. So areas, positive area, negative area, base, 1/2 base times height. 1/2, 0.5. Base, 5.5. 0.5, enter, 5.5 times height, 11 times. And I get an area of 30.25. Okay, 1/2 base times height, and I get a -42.25. Okay, so I have all of my areas done, and I'm going to go back up and take note that there's actually an applied moment right here. I'm going to want to make sure that I include in my moment diagram. This is a constant. This is linear, constant. Make sure I mark all of those. Okay, use your straight edge. So I don't have an applied moment at the end. Okay, it's not fixed. There's nothing here, so 0. And I'm going to keep running totals. So I have 25 change signs. Enter. That's my area. So I'm going to go down to -25. And if this is a 0 curve, this is going to be a first-degree curve. Okay. Now, I don't have an applied moment up here. I'm at -25, but we found that the area was 36, so 36 plus, and I get an 11. So I'm going to carry this down here, and that point is 11. And then, okay, we're slowly getting to where we're doing something fancy. I am at 11, and I'm going to subtract off 4 minus. So I come down here to 7. Okay, you see that's going to be my 7. Now, is that a positive or negative applied moment? Is this positive or negative applied moment? So I'm going to draw my beam over. Here's my external. Draw my beam over. Here's my external. If this is my external, my internal has to be equal and opposite. We're coming together equal and opposite, and that is a negative moment when I'm looking at positive beam notation. So let's come over here. I've gone to 7, and now I need to subtract off 25 kip feet plus. So I'm coming down here to 18. Okay, I have a positive area that I found of 30.25 plus. So I'm going to be coming back up. Okay, coming back up to 12.25. And then I'm subtracting off 42.225 change signs, and I'm coming down to negative 30, so it's way down here. And then I'm adding a positive 30, which comes to 0. So what is my curve going to look like? Well, I know that if I 0 order, I've got to be first degree. So we're linear, 1 degree, just like that. And here we've got a bunch of stuff going on. So I know I'm going down because I had that negative moment, so that's going down. Okay, where I have, again, if you want to take a highlight or whatever, where I am crossing, I have to have a flat moment. Okay, I can also look at, if I look at a wedge over here, that is much bigger than if I looked at that wedge. So much bigger, much steeper. Flat to steeper. So I'm going to be curving up like a parabola. And I'm going to be curving up like a parabola. And then over here, I've come down. Okay, I'm going to be curving up sharply, going flat, and then coming back down where I'm sharper at my, I don't know that I can do this. And there we go. Okay, so again, how do I know it curves like that? Well, because I have more area here, and then it goes flat, and then I have more area. So more area is steeper curve. Flat is coming in like that. So this would be what my moment diagram looks like. And I can go back with my equations, and I can make sure that we are getting the correct equations because they should be able to match the same curve.